Hi everybody, in this video we're going to go through the formulas for finding different segment lengths in circles. So the first picture is two chords. So when two chords intersect, each chord is now in two pieces. So we have this chord is split into A and B, and this chord is split into C and D. Now that's not necessarily the center of the circle, that's just wherever the two chords happen to intersect. So the rule, if you multiply A times B, that has to equal C times D. All right, and we're going to do these examples in class. So right now we're just writing down the formulas. All right, number 2, we have two secants. So you can see secant number 1 has part of that secant is outside of the circle, that's A. The other part is inside the circle, and that's B. Here's my other secant. So again, I have A is the part outside the circle, or sorry, C is the part on the outside. D is just actually that chord that's on the inside. So the formula for this is A times A plus B has to equal C times C plus D. So for both of those, the reason that A and C are on the outside of like the parentheses is because they're on the outside of the circle. So A and C are both on the outside. And if you add A and B together, that's the whole secant. If you add C and D together, that's the whole secant. So another way to think about this is you're doing the outside times the whole thing, outside times the whole thing. All right, number 3, we have a secant and we also have a tangent. So our tangent piece is just one piece. Our secant is still an outside piece and an inside piece. So I'm going to have something similar to the previous equation for my secant piece. It's still going to be A times A plus B. That's the outside piece times A plus B is the whole thing. To balance it out, because the tangent only has one piece, it's going to get multiplied by itself. So C squared, that tangent piece multiplied by itself. All right, the next picture we have a radius and a tangent. So when a radius goes to the point of tangency, that actually creates a 90-degree angle. If I connect the center of the circle to a point on the tangent, it now makes a right triangle. So a lot of times these are Pythagorean theorem problems. So we can use a squared plus b squared equals c squared. And c is that whole piece from the center to whatever that point is on the tangent. All right, for number 5, we have 2 tangents. And yes, there are 2 radii here. Basically, the reason that this all works out is you can split this if you needed to into 2 triangles. Those 2 triangles are congruent to each other. They're the same exact size because the radius is the same. They share that side. They're both going to be right triangles in this particular case because that's a tangent. But these 2 sides, the 2 tangents, are actually equal to each other. So those 2 pieces of the tangent are equal to each other. All right, so those are the formulas. And again, we're going to be doing these examples in class.